So today's topic is about multiplying binomials, and one of the ways we can look at that is using algebra tiles to model what it would look like if they're multiplied. So we go back to an old-fashioned times table type thing. We call this a mat in algebra, and we can use our algebra tiles to model things. But before we start using them, let's make sure we remember what they are. The little yellow square is a 1 unit square, so it's 1 by 1. That has an area of 1, and its counterpart in red has the same exact area except that it's negative. So that has an area of -1, or a value of -1. The green rectangle has a length of 1, the same as the unit square, but it has an unknown length x. So that has a value of x, because 1 times x is x. And likewise, its counterpart has a value of opposite of x, or negative x. So if I want one negative x, I put a red rectangle. If I want a positive x, I put a green rectangle. And likewise, this big blue square, if it has the same length as an x, okay, then each side would be x, so its area would be x squared. So a big red square would be negative or opposite of x squared. Now we can use that to model some, so for example, x plus 4 times 2x plus 3 can be modeled on a mat with using algebra tiles. So what I would do is I would take x plus 4 and I'd put it along one side of my multiplication table. So this side we'll call x plus 4. And since it's an x, and it's one of those x's, I'm going to put a green rectangle right here. And then plus 4 would be 4 of these little yellow guys. So that has x plus 4 modeled. Along the top, I'm going to want 2x plus 3. So that's going to be 2 x's and 3 1s. Okay, so now when I multiply these times each other, just like a multiplication table, we can fill in the products in here. So if I got an x by an x, that would give me an x squared. So I'm going to need one of these big blue x's to go right there, and that would fill in this square right here. Looks like I'll need another one right there, an x by an x. So x times x is x squared. And right here would be a 1. The edge of this square is worth 1, and this is worth x, so 1 times x is x. So I'll need some x's here. X times 1 is x, another x, and another x. And down along here, 1 by x is also x, and another x, and another x. And we're getting a lot of these. So we just keep filling that in. 1 by x again is x. Okay, so I have all those filled in. Now I just got this area. And a 1 by a 1 is going to give me 1. So I'm going to need a bunch of 1s. So there'd be 1 here, 1 here, 1 here. 1 by 1, 1 by 1, 1 by 1. Do that again. This one by that one is 1. This one by that one would be 1. Okay, now I've completed the rectangle, and now we can come up with the solution to this by figuring out what the products are all added together. So I just got to count the shapes and their value in terms of area. This has an area of x squared, so I've got 2x squareds So part of my answer is 2x squared. And I've got a bunch of x's. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. And I've got a bunch of 1s. 3 by 4 would be 12 1s. So you can see how we can get a product of a binomial times a binomial by using algebra tiles. Now we can also use just the distributive property sort of on steroids. My problem was x plus 4 times 2x plus 3. And just like in our multiplication problem, every part of this binomial had to be multiplied by every part of this binomial. So here I have an x and a 4. And what I could do to think about this is I could separate it to x times this whole thing, 2x plus 3, because every term has to be multiplied by every other term. And then I'd also have a 4 times 2x plus 3. And so I could distribute those things out. Let's do that on this side of the board over here. X times 2x is 2x squared, and x times 3 is 3x. I'm going to add to that 4 plus 2x, or 8x, plus 12. 4 times 3 is 12. And I can combine like terms. I got 2x squared by itself. I've got a bunch of x's. 3x and 8x makes 11x. And I've got 12 by itself. So when I combine like terms, I get the same answer we got with our algebra tiles. That's how you would do it the long way, by understanding the distributive property. But there's this term in algebra called FOIL. F-O-I-L. And it's a way to remember how to do this in a kind of a shorthand method. And it stands for first, outer, inner, last. And it has to do when you're multiplying a binomial times a binomial. So if I take this problem here again, and I look at the first two terms are the x and the 2x. So I multiply those two together, and I get 2x squared. So that takes care of first. Now the outer would be the outer two. The x and the 3 are the most outside terms, so I get 3x. And then I've got to take care of the inner. The inner two are the 4 and the 2x for 8x. And then finally the last two terms are the 4 and the 3 for a total of 12. And again, when I combine these like terms, I get 11x plus 12 plus the 2x squared. Same answer all three times. Now I've cleared my board, and I'd like to show you how to do another problem that involves a negative number using algebra tiles and also using FOIL. So the problem would be x minus 1, and notice that's now subtraction, or using a negative 1, times 2x plus 1. So we have a negative and a positive. So if we modeled it with algebra tiles, once again, we'll put one binomial along one side of a multiplication table, the other one along the other side. So x minus 1, we're still going to need an x. So I'll put an x on this side over here. But then we need a negative 1 instead of a positive 1. So instead of a yellow square, I'm going to use a red square to my algebra tile set. So this over here would be x minus 1 right here. There's x, and there's minus 1 or negative 1. Now along the top, I'm going to need 2x plus 1. So I'll put 2 x's, and I'll put a plus 1. So up here, this is x, x, and 1, or 2x plus 1. Now when we multiply these to get the products, an x times an x will give us an x squared. So we've got this x squared that goes right here and fills in that product, x times x. We're going to have another one of those, as we have an x times an x here. And then if we say x times 1, that's just x. So I'm going to fill that in with that little rectangle there. Now the tricky part when it comes to negatives, so a negative 1 times an x gives me the opposite of x, or what you might call negative x, even though it's not really negative, it's the opposite of x. So that is a red rectangle right here. A negative 1 times another x will give you another opposite of x here. And then a negative 1 times a positive 1 will give you a negative 1. So I'm going to need a little square right there. So now this time when we're looking at our final answer, the final result of this, we look at this, we've got 2x squareds. But then when we look at the x's, we've got 1x that's positive and 2x that's negative. So if you remember a thing called zero pairs, that a number and its opposite combine to make 0, what's going to happen is these two positive and negatives are going to cancel each other out. That's going to make 0. X, no matter what x is worth, you take the opposite of that value, opposite of x, and you put them together, they make 0. 7 and negative 7 make 0. No matter what you put in for x, negative 12 and positive 12 make 0. So these two will go away, and I'm left with a negative x, or subtract x right there. And then I've got a negative 1, so I'm going to put minus 1. And you can write that 2x squared minus x, or 2x squared plus negative 1x plus negative 1 if you prefer addition. But it tends to be simpler to write it with subtraction. Now we can go back to that idea of FOIL and answer this question using that as well. We start with x minus 1 times 2x plus 1. And FOIL, remember, is first, outer, inner, last. So the first two terms are x and 2x, so that gives me 2x squared. Then the outer two, these two, x times 1 is x. Then the inner two, negative 1 and 2x makes a negative 2x. And then the last two, negative 1 and positive 1 make a 1. When I combine like terms on this one, the 2x squared is by itself, so we get a 2x squared. But the x's combined, I've got 1x that's positive and 2x that are negative. So if I have an x and I spin 2 x's, I'm down 1x, or subtract x, or you can put negative 1x. And then I've got plus 1. Same answer by using algebra tiles and FOIL.